So in this video, we're going to talk a little bit about trigonometry. And in trigonometry, we have an acronym that we like to use that is going to help you along the way when it comes to deciding which function in trigonometry to use. And you may have seen this before. So, ka, tawa. And to be honest, when you see a trigonometry problem, I would really strongly recommend you actually write this acronym down, and we're going to explain that right now a little bit more in depth about what it actually means and how to apply it. So looking at the first one of the things with trigonometry that you're going to have to start to get used to is a new symbol, and that symbol is simply theta. Now, theta just represents an unknown angle. So we add this theta to the end of each one of our trigonometry functions. So we have our sine, cosine, and tangent. And when we put these into the calculators, when you look at your calculator, you will see it as sine theta, cosine theta, and tan theta. So that's in your formulas on your calculators, that's how it's going to look. Or you might end up just having sine, cos, tan. You may have heard of those terms. Now, in order to be able to accurately decide which one of these functions you need to use, we need to have a look at a right triangle. So let's draw one just very quickly here. Remember, excusing for artistic interpretation, this is really just very, very quickly, and we're going to label this corner in here as our right triangle. Now, we're going to label this triangle ABC. Now, let's put theta in this corner here. Theta is either going to go in this angle here, or you may find it up in this angle here. It really doesn't matter which one it's put in. What does matter is the fact that you remember that where it is going to dictate which side is the opposite and which is the adjacent, because the opposite side and the adjacent side are labeled in relation to where theta is, whether it's in this corner or it's the opposite. Now, what I like to do when I am finding opposite and adjacent in a right triangle, I put a dot in the middle of the triangle. Doesn't matter where, it's just somewhere in the middle, because from that point, I can now find out where the opposite side is. Now, I go from the corner where theta is, and I'm going to draw a line from that corner through that dot and continuing on straight all the way through. And you'll notice that I've actually crossed outside the triangle now. So line AB is our opposite. Now from there, the next line that I know is the hypotenuse. Now the hypotenuse is always the one that is opposite the right angle. And if we know that this angle here is the right angle, and we know that because of the way it's been labeled, we draw that line again from that angle through the middle, and we keep drawing until we leave the triangle. That side that we've just crossed, that one, so line AC, is the hypotenuse. And then finally, the one side that's not been crossed, so we've got this side here, it's just the one that's left. So line BC, that one is our adjacent. Now, believe it or not, it doesn't actually matter where theta is. The process for finding the opposite and adjacent always stays the same. So let's try it again with a different, we'll go the same triangle. We've got a right angle here, and we're going to put theta up in this corner here. A, B, C. Now, we put our dot in the middle, and we draw a line from theta through the dot until we leave the triangle. So now, line BC is opposite to theta. We take our line from the right angle through the dot until we leave the triangle. Remember, line AC is still the hypotenuse. And then the last one left that hasn't been crossed is line AB, which is the adjacent. And that's how we find opposite, adjacent, and hypotenuse to later on use in these trigonometry functions. And we're going to go into that in our next video.